Welcome to the EarthWorks podcast, where our team will share the jargon of carbon with many of the turf friends we've met over the past 35 years.
Hi, everybody. This is Joel Simmons for another EarthWorks podcast. If you have been listening to our podcast over the years, you have certainly heard us talk about the name Jerry Brunetti. Jerry was my business partner and certainly the founding member of this organization that we so dearly love called EarthWorks. I met Jerry many years ago, back in the days when I was a county extension agent for Penn State in Northampton County, Pennsylvania. And the story goes that I was working with a grape grower in the county, and he said to me that, "Hey, there's this guy down the hill that's brilliant, and I don't know what the hell he's talking about, but I think you might, and I think you should get to know him." And that person was Jerry Brunetti. And Jerry got to know me a little bit. I was a young punk, probably of 24 years old. I had just come out of the university. I was finishing up my master's degree, so I was the smartest guy in the room by far. And Jerry, with great patience, spent a lot of time de-educating me and helping me understand how a soil really works. And then many years later, after I had left Extension, we had stayed friends, and he had known that I was not very happy in the job that I was in. And so why don't you come back and work for me? Now, Jerry's business is animal health care, and I had no interest in working with cows. So I said, is there something that we can do, in the plant world? And so we worked together and we built EarthWorks. And we were actually going to be a franchise lawn care company, which is kind of funny. And I had been working at a pretty good sized job, and I left my job on a Friday, and I called him up on a Saturday morning. I said, I don't want to be a franchise lawn care company. Why don't we take the products that we had developed? And we had developed, or I should say, really, he developed Replenish 545, which is still probably our best product, and our soil conditioner we call Kick. And we thought this could be a really good foundation for lawn care companies. And so I started cold calling lawn care companies and started talking to them. And I think our first season, the first year, we might have grossed $60,000, which doesn't pay for food much after all the expenses of a business. But Jerry and I worked on this a lot together and developed the entire EarthWorks line together. And he continued to teach me and teach me and teach me over all the years. I spent 30 years in the EarthWorks office with Jerry. And as many of you know, we lost Jerry to non-Hodgkin's cancer 12 years ago. And it's been a big loss. But fortunately, we still have a lot of videotapes of Jerry, and it keeps the brain trust active, and it allows us to really hear his voice and to continue to learn from him. So I call these series that I pull out some of Jerry's old recordings, Still Learning with Jerry. This particular one that I want to play today is, I think he entitled The Holy Grail of Crop Health, Plant Secondary Metabolites. And one of the things that Jerry taught me more than anything, and was really instrumental and the backbone of the entire EarthWorks product line, was the concepts of remineralization. If you listen to any of the podcasts that we do with Lawrence, we talk a lot about Jerry together because we both worked with him pretty closely. And Lawrence talks a lot about this concept of remineralization and how there are, 70 trace elements, and conventional wisdom tells us there's really only 14 that the plant needs, which most scientists, certainly better scientists, have debunked over the years. Plants will take up all 70 elements. They might use them in minuscule amounts. They might be a key to unlock an enzyme or something else. But they're extremely important. So Jerry was very adamant about making sure that there was as much complexity in our product line as possible, and as much complexity when he was working with his farmer clients, making sure that they were getting the minerals that they needed in their soils, because those minerals, as he's going to talk about in this clip you're going to see, is really the backbone of building the healthiest plants. They build the enzymes, they build the cofactors that make everything else important. And it's these minerals and proteins and enzymes that are really creating, the health of the plant. So again, he talks a little bit about this in this clip, but again, we've been told for so long that we only need 14 essential minerals, and I think we know for a fact that that's just simply not true. So having this diversity of mineralization is very important, in particularly in these managed soils or these engineered soils that we find in the sports turf industry, in golf greens that are made out of sand or athletic fields that are built out of sand. Now we have stripped away the foundation of this sustainability of minerals because there aren't minerals in sand. So it's imperative that we add these minerals back. And some of the most important products that we have for that are products like Renovate Plus, which is very, very mineral dense. We add rock minerals to this. We add things like kelp meal that have a lot of minerals in it. And these products provide this remineralization that is so essential in these managed and constructed soils so that the plant can get what it needs. So constantly adding these back in small but frequent basis is very important in making sure that the plant can then utilize these minerals, draw them in, and then start building the imperative structures that they need, like the enzymes, the amino acids, the peptides, the proteins. These are all building blocks for these structures that create the health of the plant. So if we think for a second that we can survive and build healthy plants in a managed soil without minerals, we're mistaken. And it's this mineralization that is so important. And he talks about it again in this. This is an interesting little clip that I found from one of his lectures. He talks about essential oils. He talks about pollinators and how important the pollinators are to overall health. And again, going back to this idea of having these minerals in the soil so the plant can build the strength and draw in these pollinators. I mean, without the minerals from the soil into the plant, the pollinators may not actually be drawn in and effectively work. So he talks about some of his products where he uses essential oils, which are mineral based, that help fight off some diseases. But again, I like to be able to send a little bit of Jerry Brunetti your way when I can, and I think this is a relatively short clip, but it does give you an understanding as to the knowledge base that Jerry had. And we say here at EarthWorks that Jerry was still 10 years ahead of his time. He's been gone for over 10 years. I think he's still 10 years ahead of his time. And what we continue to learn from Jerry Brunetti is pretty significant. And if you want to find out more about Jerry, you can Google Jerry Brunetti. He was one of the biggest keynote speakers at Acres USA, which is the sustainable agriculture, regenerative agriculture industry, really. I mean, they're the head of the industry. They publish magazines and put out a trade show every year and bring in the best of the best. And Jerry was always one of the very top speakers in that organization. In fact, I tell stories where I'd go to Acres, and one of my favorite stories of Jerry was we would go to Acres. I remember Lisa Kiefer and I think we've said this in a podcast before. We were coming down the elevator, and we hear this psst, psst, and we look around, and I'm like, what is that? And it's Jerry hiding in the corner because, we're trying to get out to dinner. And he said to us, look, if I got to get out the back door. Or he literally was just, hoarded upon. I mean, there's so many people that wanted to get to know Jerry and talk to Jerry and understand what was in his head. He literally couldn't walk around the Acres conference without a dozen people surrounding him at all times. You could always tell where Jerry was because there was a crowd following him. So we had to sneak out the back door like some rock star, I guess. And he was, in many, many ways, a rock star in the regenerative agriculture industry. This is just one piece. I think it's a good one. Again, he's not talking about turf, but he is talking about how the system works. So it's not going to be a direct correlation to turf grass. But I think if you listen through this, you will see the connections and the reason why we built the way we did, and you'll certainly get to understand, how smart Jerry Brunetti was, and of course how much we miss him. But the things that he is talking about are relevant to turf. The same things that are happening. He might be talking about animal or human health, but the analogies are still the same. And keeping the healthiness of a plant, any plant, grass plants, forage plants, it doesn't matter. We still need to have minerals. We still need to have biology. We still need to have the basic building blocks. And again, this little clip is Jerry talking at a group, I think in Australia. And there's some people that are going to ask questions, and it's kind of interesting seeing the interaction. But you can certainly get a feel for how Jerry spoke and his breadth of knowledge on the subject. And again, I think we've done this 2 or 3 times now, these little talks with Jerry. And each time that I do it, I still learn something. I mean, after all of these years, just watching one of his talks, I'm still picking something up, which just doesn't say a whole lot about me, does it? But I think if you listen to Jerry talk, you're going to feel the same way. There's always something in what Jerry Brunetti had to bring to the table that allows us to really continue to learn. So let's continue to learn with Jerry. Enjoy this, and I appreciate you watching the EarthWorks podcast. Again, I would encourage you to subscribe, and if you haven't watched some of the past ones, like in particularly the one Jack Higgins and I did recently with Dr. James White from Rutgers on the subject of rhizophagy, if that's the only one you watch this year, watch Dr. White, because he really opens the door to something quite amazing in the plant world. But today, let's listen to some Jerry Brunetti. Thank you so much.
There's a whole lot of interest on this from animal and human medicine, but also for plant protection. So there's a couple experiments that I'll give you a perusal of that we did the last couple of years, making our own concoctions. But when you're dealing with the plant primaries, these are the plant primaries, and then down here is what we call the secondary. So if you look at James Duke, Dr. James Duke, he did a compendium over about a decade of about 1,000 different plants with 3,000 different compounds found in these plants. For example, tomatoes, they found like almost 400 different compounds in tomatoes. It's probably a lot more than that, but that's where they stopped. And what they're talking about are all these secondary and primary compounds, but a lot of them are these secondary compounds. And these are compounds that plants make for a variety of reasons, including pollination. So the fragrances, molecular signals down in the root ball to attract beneficials that are going to attack not so beneficials. So it's perfume, it's color. And 1% of the PSMs are volatile, and there's 90 plant families with over 1,700 volatiles that they've actually examined. And so they're called terpenoids or terpenes. Another word for that is essential oils. They happen to be cousins to the carotenes. And then there's the phenylpropanoids, and these are kind of in the flavonoid family. And then there's the fatty acid derivatives, and there's the amino acid derivatives. So there's all these compounds that plants make to protect themselves. And what's great about this is that unlike a pesticide or an antibiotic, which comparatively speaking is a fairly simple molecular group, the plant secondary metabolites that are emitted by plants are incredibly and vastly complex. And the reason why they're so important is because if this is the pest here and this is a cell membrane, these are all what we call the organelles within that cell that are affected by plant secondary metabolites. So the mitochondria, the furnace is affected, the enzyme systems, the channels or ion channels, the transporters, the signal inductors, the cell membrane, all of these locations on that test target site are affected by plant secondary metabolites. So what that says is, first of all, if you're using a cocktail of plant secondary metabolites, and plants make cocktails, by the way, or you're making a cocktail, you have a huge variety of molecules being able to target a huge variety of targets. So what does that mean? It means that resistance is futile. That's what it means. The pest has a hard time building resistance because there's just too many ways that that organism can be shut down. Pollination is, absolutely essential. And what a lot of people don't realize is it's not just the honeybee that is a primary pollinator, but even your bats and mosquitoes, or mossies as you call them, mice, ants. Beetles are probably the biggest group of pollinators, beetles. Birds, wasps, butterflies, miscellaneous mammals. There's a lot of guys that are involved in romance. Pollinators' perceptions. It's a function of the number of compounds that come out of the blossoms. It's relative to the concentrations, the intensity of the combined scent, or the bouquet. The bouquet is like a complex smell. That has a lot to do with it. The memory that particular pollinator has of the odors. And flowers produce species-specific signals to increase foraging efficiency. So in other words, plants know how to seduce their pollinators. That's what it comes down to, if they're healthy. Honeybees can distinguish between cultivars within a species. So a scent can consist of 1 to 100 volatiles. Usually it's in the neighborhood of 20 to 60 volatile substances. And honeybees use all the volatiles to discriminate subtle differences. And that's one of the reasons why I think having a lot of variety in your farm can actually be a very good educational tool for the pollinators, because they get to choose. I mean, I've seen this where I've grown buckwheat, which I always thought was the best pollinator for honeybees, and it was not really attractive to honeybees, because I actually found out that my buckwheat was flowering at the time when other pollinating species were blooming, and they actually preferred to pollinate the non-buckwheat species. Gemotherapy is buds, right? So this is a form of medicine in France called gemotherapy. And so the resin that's produced by the bud when it's dormant is actually loaded with these compounds that make up the raw materials for one of the best, in my opinion, medicines for insects or animals, and that's called propolis or propolis. Anybody ever use propolis for a sore throat medication? Man, that stuff is fantastic. I mean, it just always works. And that's because it's incredibly complex, and it's loaded with these resinous compounds of bees. It's called a bee glue. Anybody keep bees here? Yeah. So you know about propolis. You chew it once in a while?
Oh, yeah.
Yeah. Interesting work done on medicine, on propolis. All these particular medicinal, anti-ulcer, bacterial, viral, fungal, inflammatory. This is a plant secondary metabolite composite. If you do have, now you don't have varroa mites here yet, is that what I heard? And you don't have tracheal mites here yet either? Tracheal, they attack the trachea. You don't have those here yet? No? Well, we have both. Plus we have colony collapse disorder, thank you. And we're in bad shape in the United States with bees. I mean, we're losing, 30% a year, and there's only so far you can go with 30% attrition before they're going to have a big honeybee shortage this year in the almond country of California. They don't have enough bees. They just know that now. What's that?
It's not such a bad thing, really, is it?
In terms of the indigenous bees, you mean, or just the almonds?
More the collapse of the industry.
The collapse of the honeybee industry or the conventional honeybee industry?
The almond industry.
Almond industry, yeah. Well, the thing is, we need bees for more than almonds,
But I think maybe it will take such a collapse and such a lucrative business for people to then make
It might. Yeah, well, it's that old grandfather saying, the good news is wrapped up in the bad news kind of thing. So sometimes we don't do anything until we react to a crisis. But, I think it's one of the reasons why there's a lot of focus now on the indigenous pollinators, because they're in jeopardy and we've ignored them. We don't even understand them, because the honeybee is really it's not a native to North America. It's an alien species. It's brought over here, but it's incredibly aggressive. As a matter of fact, there's some interesting research done on the colonies, the first colonies in the 17th century in North Carolina, or where they brought bees with them, and they actually felt that the bees created a lot of disruption for the native pollinators there. Actually created food shortages for the Native Americans, believe it or not. I mean, that was pretty.
What did they call it? They called it something.
Say what?
They called it the stinging wasp or something, didn't they? The natives.
They called it the stinging wasp, yeah, right. Although they're pretty, I mean, the Caucasian bees are nicer than the Italian bees. It should be the other way around. I don't know why they call it the Italian bees, but the Caucasian bees are supposedly easier going. I don't know, but here's a recipe that's been used with a great deal of success on these mites. So it's 25 drops, which is about a milliliter, a cc, of oil of wintergreen to a pint or half a liter of honey. And you take 25 drops, the same, of lecithin to emulsify the oil. add it to a quart jar, fill the other half with water, a liter jar, and you can also use these other essential oils, and you just put it out free choice and let them have at it. And it seems to build an immunity to these mites. Or you can make basically a wet t-shirt party for the bees, you know? So you basically take 4 cups of sugar, cane sugar, not high fructose corn syrup sugar, by the way, which is what they're feeding the bees. It's one of the reasons why I think we're having a lot of issues with the health of the bees. They're taking all their honey, which is an incredibly complex energy source. It's loaded with amino acids, fatty acids, minerals, vitamins, unidentified factors of many kinds, and giving them high fructose corn syrup. And you wonder why you have we know what high fructose corn syrup does to us. So you don't use that. Use some cane sugar, and then you just take, again, about a milliliter, or 25 cc's, excuse me, about an ounce of essential oils, mix it with 4 ounces of the patties, put 2 patties on top of the brood box. They seem to kind of like swim through this stuff. They just coat themselves up with it, and it actually bathes them in these phytoalexins, or these plant secondary metabolites, and it kills the mites. It's amazing. So plants, I don't care what kind of plant you're growing, there is this incredible system going on here where you have alleliopathy. How many people know what alleliopathic influences are? Like you have a black walnut, you know, there's a number of chemicals that are exuded out of the roots so that other plants don't do very well growing around the root ball, but it's also done because these are strong antifungal agents. A lot of those alleliopathic compounds are what they call alkaloids. Alkaloids are dumped a lot in the root ball, and alkaloids are really good against things like nematodes and root fungi. When a plant is hit by a pest, you start getting signals, and these signals are basically initiated by a protein molecule that comes from the pest. And this protein molecule then starts a cascade of an immune reaction, just like if you get infected. You know, there's an immune response. It's called the phytoalexin response. I'll talk about that a little bit. That starts revving up communication molecules like jasmonic acid and salicylic acid, which is another word for aspirin, right? To start revving up these phytoalexin compounds and then start going to the site of the infection or the attack. So these are wound signals. They call them green leaf volatiles. Those are other signals. And so all of these, there's communication going on in the root, in the canopy, and especially to other plants that have not yet been attacked. That might be the most impressive part of the plant secondary metabolite phenomena, is the communication downstream, and I'll show you some slides that verify that. The silkworm is a model. Somebody was telling me, Bonnie, you were telling me, where is Bonnie? Is she still here? Or is she out doing things? But she's talking about the wasp that you guys are going to be using as a parasitical wasp that has...
Mastitis?
Right, but they're going to use silkworm eggs as the host, so they can actually import. That's interesting to me, yeah. But you know, silkworms, actually the silkworm industry was attempted in Georgia way back in the 1700s, and it flopped, collapsed, primarily because they were trying to move the larvae into houses that were made out of bald cypress. All right, bald cypress is what? Taxodium. It contains this furaldehyde, which is a growth inhibitor at a mere 1 part per million. So that tree vapor actually was a plant secondary metabolite insecticide that killed all the silkworm larvae just by hosting, you know, those silkworm larvae in a 17th century brooding house. So the dilemma of plants is grow or defend. What do you think they're going to do first? Defend. Can't defend, can't grow. Right. Photosynthesis, when everything's going right, you know, you've got lots of adequate amounts of nitrogen. Okay, now we're talking about the funny protein thing again here. Keep that in mind. We can make these things called terpenoids, the essential oils. And if it's limited, then the first place that those nitrogen compounds are going to be utilized is in the roots. Without a root, there's no top. And then the nitrogen is used to make alkaloids. Alkaloids are very rich in nitrogen. You know, most of your alkaloids are nitrogen-rich compounds. So it goes to the root first if you're deficient for the whole plant to have adequate amounts of nitrogen. When there's enough nitrogen, the next bouquet comes along, then it can start sending some to the young shoots because they're very vulnerable. And they're getting what? Terpenoids, essential oils. So complete nutrition plays a role in all of this. Too much nitrogen, what does that do? It shuts down the actual complete protein process and you end up with a deficiency of alkaloids and or terpenoids. So disease resistance in higher plants, they're basically in 4 groups. So before they're infected, there's things called prohibitins and inhibitins. After they're infected, they're called post-inhibitins and phytoalexins. So these things in healthy plants are already there, and they're actually the immune system of the plant that disallows organisms to infect them. And if they happen to become infected and they're still strong enough to ward it off, then they come up with these other immune responses. I'll call them like plant antibodies, if you want to call it something similar to what animals respond to. Plant antibodies are the post-inhibitins and the phytoalexins. This is an example of a pre-infective response with a number 2. This is an inhibitin. This is a potato that they cut lengthwise for late blight. Phytophthora infestans, 14 days at 18 degrees C. There's the site of the infection, rotting infective tissue. So they find out that this phenol, called coumarin, increases up to 20 times. Another phenol, called chlorogenic acid, also found where? In coffee. Chlorogenic acid is a really important antioxidant. That's why it's good for people, by the way. Coffee has more antioxidants than any other beverage, by the way. That's why I like a little bit of it. Yeah. Hydrocinamonic acid increases 300%. Similar phenolic increases. And one of the things that's great about coffee is caffeine is an alkaloid. Anything that ends with the word "ine," like nicotine, that's an alkaloid. Good insecticide, right? Caffeine is a good sluggocide. Sluggocide, right? So these phenolics are produced after the process starts. Bird's foot trefoil, that's a legume. And legumes are very susceptible to mildews. They produce this cyanogenic glycoside. What's that word you see there? Cyanide, right? So legumes produce cyanide because, and all of them do. String beans, soybeans, because they're very susceptible to powdery mildew. So here you're talking about an enzyme that converts the cyanogenic glycoside into a much more potent cyanide right here that actually kills the mildews. Okay, so this is management of late blight with alternative products. This was a scientific paper that was produced. Some were as plant extracts. What I mean by that, so they made a water infusion or an alcoholic extract, or they did an essential oil. It was different ones. So these are some of the plants that they used. Crucifers. So we're talking now downy mildew on crucifers. What they found out is some of the heirloom varieties had very high levels of this what? Glucosinate, that's a sulfur compound. And glucosinates are extremely healthy for animals and people to eat because they are what they call liver conjugates. That means they detoxify the liver. It's interesting how these compounds can go across, animal and plant species with similar objectives, in that getting rid of the bad guys, all right? So this one that has 630 micrograms per gram of this glucosinate was very resistant. This was an heirloom variety. This was a new hybrid variety. So what are they saying is that the old varieties, we've lost a lot of the innate plant protective compounds that are in there for the purpose of size, faster growth. Some University of Texas work talks about, nutrient density disappearing. And one of the reasons why, besides what we've done to our soils and what we've done to our soil biology, as well as our soil mineral composites, is they've actually hybridized things so things grow faster and bigger. Well, in the process of making a plant that grows faster and bigger, you get what's known as the dilution effect. Because plants are almost only able to take up so much at any given time, and as you force that plant to grow bigger and faster at the same time, it doesn't have the efficient capability of bringing in the nutrient density. And the nutrient density, those minerals in particular, are the raw materials to make these things. You can't make those plant secondary metabolites unless you have the mineral nutrition coming up. So the heirloom varieties sometimes in and of themselves have this particular innate ability. This is an interesting experiment they did called the onion bait and switch. So here's these sulfur-bearing amino acids. Enzymes turn them into this diallyl disulfide, one of these medicinal sulfur compounds that make garlic so medicinal for animals and people. Allicin is another one. There's a whole variety of them, but this diallyl sulfide actually is a deterrent to onion pest, with the exception, and this is called the coevolutionary arms race, with the exception of the sclerotorium infection. So what happens is the sclerotoria will germinate in the presence of the sulfide and the absence of the host. So what they do is they actually basically allow this onion to be in the ground, take it out, and the disease shows up, and there's nothing for it to eat, and it just wipes the disease right out because it starves itself. So it was an interesting how, for example, cabbage loopers. How many people know what cabbage loopers are, right? I mean, they're a prevalent broccoli and cabbage pest, the green worm. So they seem to be attracted to the PSMs in the brassicas, these sulfur compounds, the glucosinolates. They're attracted to those when everybody else is repelled by it. So they've learned how to evolve by saying, not only are you not going to kill me, but I'm confined you now with this other deterrent that everybody else seems to have an issue with. But guess who else is attracted to this particular disulfide? That's why I don't remove their nests. Wasps. Right. Pow. So around my 6,000 square foot garden, I've got big paper wasp hornets, and people say, oh my God, why don't you take care? They don't bother me. I'm not edible, you know? As long as I don't go and punch the house down. I leave them alone, they leave me alone, but I watch them out in the garden, and they're nailing all my cabbage loopers. They're attracted to the same emissions that the cabbage loopers are. So as long as I have predators, I'm going to win that war. And if I don't, I can always use some other kind of organic interference, but you can see how that whole system is working. So apple resistance varieties, here we go again, same thing with the different apple varieties. It's the same thing as with the cabbage varieties. So here's some post-effective phytoalexins. Now phytoalexins is the last responder. These are the guys, like when you finally have problems, the phytoalexins are the 911 responders. This is like stage 4 of the immune system kicking in. The other 3 aren't getting the job done, the phytoalexins kick in. So these are all examples of these. I'm not even going to mention them to you in terms of names. Benzoic acid is the easiest one to pronounce. Pisatin is another one, brown rot fungus, and so forth. But these are all last-minute 911 responders for an infection. But again, you have to remember that you can't build these things unless you've got nutrition. You can't build them. So often the reason why you have crop failure is simply because maybe you have weak hybrids, so there's an innate genetic thing there, or you might have weather stresses, too much rain, too much drought, that disallows nutrition to be taken up into the vascular system of the plant to make these finished compounds, or you don't have enough in the soil to begin with. So the coevolutionary arms race, phytoalexins, plant first responders, produce it in quantity, make it fast, produce it timely at the right location, and it must be fat soluble. Why? Because the pest cell membrane is what you're after. Remember that circle I showed you, how all the sites are on that pest cell membrane? So it's got to be a fat soluble poison or drug or whatever you want to call that thing that plant's making. It's got to be fat soluble because the pest has got a fat soluble membrane. Legumes, defense by hormones. So isoflavones. Isoflavonoids. Flavonoids, they're in the flavonoid family. What else is in the flavonoid family? Hesperidin, rutin, these vitamin C compounds, flavonoids. And these are considered what? Phytoestrogens, right? So these are used by medicinal practitioners for balancing estrogens. If females are low in estrogens, this is a good way to get a not harmful synthetic estrogen. It's a phytoestrogen. And so it's a steroid mimicker, and it interferes with the nutrition of the fungus, and it affects the cell membrane's permeability. So all legumes have these hormones. And if you look at, this is interesting to me because the most potent isoflavones, there's isoflavan. Isoflavan is produced by the most sophisticated of all the legumes, which is who? The lotus. You know, the sacred legume of legumes. Produces the most potent, which is maybe one of the reasons why the lotus is recognized for being what it is. Systemic activated resistance. All right, so this is part of how the thing works. The synthesis is immediate, it can be detected within an hour, and it peaks within 2 to 3 days. So once it gets bit, there's a systemin protein that's initiated, you know, by this biting of the insect, and that saliva contains this protein. And there's a feedback loop system that starts kicking in. This systemin is this signature protein that causes now the genes to suddenly change. Expression of the genes switches get turned off, and jasmonic acid acts like a prostaglandin, which is a hormonal substance that animals utilize in order to express healthy gene expression or a reaction. So jasmonic acid kicks in. That's modulated by what? Salicylic acid. It's one of the reasons why they've done some experiments with salicylic acid as a foliar spray, and it seems to help give plants more resistance. Can you use synthetic salicylic acid or just the stuff you can extract from like willow? The chemistry of the plant is involved with changing so that the plants can protect themselves from overgrazing. And I got some examples of wild animals doing this, and cows are involved in that whole cascade. Yeah, you definitely change the chemistry of the plants where overgrazing is actually halted in many ways by the actual phytochemistry of the plant radically changing, where there's more tannin produced, there's more alkaloids produced. These are salicylic-rich vegetables, so when your doctor says take aspirin or baby aspirin to keep your blood thin, it's completely a worthless attempt, because salicylic acid is not just salicylic acid. If you take it as aspirin, it's called acetyl, ACETYL, salicylic acid. It causes hemorrhaging. It causes bloodletting. And salicylic acid that's found in nature doesn't have that acetyl group. So if you want to get aspirin in your blood, and these researchers did this on Tibetan monks that were vegetarians that ate a lot of vegetables, these are salicylic acid-rich vegetables that don't have any downside to them. You won't end up with stroke or ulcers. And these are the fruits. You notice the dark color? Berries, the dark berry colors, these are rich in salicylic acid. Odor blends of attacked plants. Over 200 separate compounds. Directly affects herbivores' behavior. It attracts the enemies of the attacking herbivores, like predatory mites, parasitical wasps, hornets, like I just mentioned on the cabbage looper. So these compounds are messengers. They're messengers, right? Release of stored plant compounds, which are the post-inhibitins again. So now we actually have an insecticide that's being released. And we have a biosynthesis of new volatile compounds that weren't there in the first place. This is the stage 4 911 kicking in. And this is interesting. Predators can distinguish infestations by its host herbivores from non-host herbivores. So they know that that plant is attacked and that same species over here is not. They don't waste any time. So what you can do, this is an example of some USDA studies. You can actually, if you want, they found out here, they clipped sagebrush release volatiles near cultivated tobacco plants, and they increased the mortality of young Manduca sexta caterpillars merely by taking sage, wild sage that was growing near the tobacco plants, and damaging them physically by clipping them, releasing volatiles. So what does that tell me? Tells you can take volatile substances that you can make on your own and waft them over your plants. And we've done this last year up in New York State on tomatoes. When late blight came in, we made a mixture of essential oil mixtures with that PhytoGuard I'll talk about here in a little bit. And as long as we were preventatively treating the tomatoes, this was the only guy in the neighborhood that didn't get clobbered with late blight. He sailed right through late blight, and all of his neighbors collapsed with it. Because when that stuff, it's like AIDS when that stuff hits. I mean, it's once it attacks, it's pretty hard to turn it around. But he kept his tomato patches, intact merely by preventatively spraying volatiles on those plants, in effect creating some kind of innate immune response in that tomato plant where it did not come down with the phyto.
In some sort of spray, or had to be
sprayed it with a backpack sprayer. Yeah. I gave him some. It was essential oil solution in a surfactant, and he just put in a 1 or 2% dilution in the water and just sprayed it, and that was the end of it. And he did it not once, though. He did it like every 7 to 10 days. Because he heard what happened was late blight hit the southern part of the United States, and everybody knew it was coming north. So he had some time to go out there and prophylactically prepare his tomatoes with it. And so it was a couple of weeks before it finally got up to the Finger Lakes of New York State.
We get it every spring and summer.
Every spring and summer. Right. It's late blight.
Yep.
Right. And this is just the same species that's in the roots of your ivy trees too?
Different species.
Different species.
Yeah.
Right. Okay, that's what I thought. I'd have to be. All right, so this is some trials I did with a guy up in Canada with this similar product. We put together a concoction called PhytoGuard, that's what we called it. And this was on, now this was on conventional, and I hate these kind of trials because these are potted plants grown with chemistry in greenhouses, you know. Everything that I wouldn't do. But that was the trial. So we said, okay, if it works on that, probably works on a lot of other things, but I don't like those trials because it doesn't take in consideration, you know, good soil issues like biology and chemistry. And it doesn't take into consideration, you know, cultural practices. These are conventional Lebanese cucumbers grown in pots on trellises. You'll see them here. And so this was on 2 spotted spider mites, which are pretty tough to kill, with a 1% dilution. These are the dates of application: August 16th, 25th, September 3rd, and 13th. And we had 100% results as long as we got in there before the pest. And we put a polymer on there called Extend. This is not for erectile dysfunction, by the way, guys. This is just a polymer to keep it wrapped around the plant. And so this was on downy mildew, and we also had really good results after a 15% infestation of downy mildew already began. So I didn't think it would work that well because the infestation was already underway, but this is what it looked like starting out. You can see the backpack sprayer in those greenhouses. This is September 6th, and this is the treated September 28th, and this is the control. It's got about, I'd say 8 different essential oils in there, and it's got a castor oil base, and it's got some organic surfactants in it, and the Extend is an organically approved polymer that they use for foliar sprays so that nutrients stay on the leaf without rolling off. That's what it is, yeah. It did it on black sooty mold, on scale, from scale. This was on the treated scale. Very effective on scale, which is a tough pest. Scale's not easy to get rid of. This is on magnolia trees. You guys have magnolias down here? Yeah? On peony, on botrytis. These are the applications on that. This is typical, very common. It doesn't usually kill the peonies, but it was nice to see that we could get rid of botrytis on peonies. We just checked sensitivity, insect by insect. This was not an actual field trial. This was an insect by insect trial, so we did them on all these particular pests at those dilution rates, and they were effective on all these pests in that dilution rate. So this was number of dead eggs. This was a certified consultant in Quebec, Canada, that did this research, and I won't spend a lot of time, but these were different, 0.5%, 0.5%, 1.5%, 2%, 1%. This was another variation of PhytoGuard. We called it Phyto Plus, just different combinations. The first application, by reducing the adults, we also reduced the egg number. So here's the untreated check. And so the egg numbers weren't reduced, but you see what happens here. This is the forbid insecticide, the conventional treatment. You can see that had the highest control, although we were far apart on this one and this one and this one. So we did knock, you know, the adults back to the point where the egg levels just, and the consultant called me up. He said, "Are you sure there's not any kind of chemicals in this stuff?" And I said, "No, there isn't. Why are you asking me?" He says, "We've never seen these organic insecticides work on killing the eggs, frying the eggs." He said, "This fries the eggs." And this was on dead mites. So again, the same thing. We compare it to forbid. You know, we at the very end we end up with similar results. Not quite as good as the forbid, but good enough. You know. And this was on the powdery mildew and percentage of infected leaves. So you can see what happens is right here, the untreated check, you're starting to see the percentage go way up to 70%. On the phytoguards, you know, they drop down here. And what this says right here, there should have been another treatment if you wanted to keep it going. Right about in here, because all of the levels were down, very low compared to Nova in this, a fungicide at 5%. So it's very encouraging to see these kinds of phytoalexins being produced. Number of spots from powdery mildew, the same thing as with the amount of damaged leaf surfaces. So I'm not going to spend a lot of time. Copper, this is just an example. Adequate amounts of copper create this polyphenol oxidase. So biosynthesis of lignin. Where do you want lignin? In your roots. Why? Tree bark protects plants in the root ball from nematodes and fungal diseases. But you can see all of these things that are associated with just one mineral, copper, but not excessive copper, right? And you can see here, what's happening here is we're getting all these flavonoids being produced out of the root zone, and we're getting amino acids and sugars produced out of the root zone. So the root ball is an amazingly manufacturing plant of all of these compounds, as well as the terpenoids that are coming out of the canopy. And of course, the plant secondary metabolites. This is Huber's work. I just synopsed some of his work out of one of the textbooks, but you can see all of these minerals are all associated with, preventing diseases. And I showed you this slide earlier. Okay, I think that's it. Thanks for listening. Have a great time. Appreciate it.